Rex? Good news will come to you by mail. That's specific. By mail. What type of good news even comes in the mail? I guess like a wedding invitation or something. I feel like all I get in the mail anymore is like tax forms or like boring like adult stuff. Okay. Where am I going to start with this? Meow, meow, meow. Ugh. Hmm. I want to do all four of these problems, but I can't do all of them at once. Um, First two non-zero terms. Okay. I think this one has a small thing that we need to work on. So I think we'll start with number two. So I solved this one. I probably did it. I think I did it right. I shouldn't say probably. Actually, can Wolfram Alpha figure this out? I'm kind of curious. Can we verify? Is it z minus 1 squared y double prime 4z minus 1. Wait, is plus or minus? Plus. Five z minus 1 squared y equals 0. I would do new ones. That's a good idea. It's just that for this homework, I've already started on all of them. Oh, right, it looks like this stupid thing. And who knows what this means. If I click on it, oh, it doesn't click through. This is the same song, but sped up. So yeah, I've already started on it because these questions are all like really difficult, and I pretty much always have to end up going into office hours in order to get through these homeworks, and it's not worth it to go to office hours unless I've attempted the problems on my own first. I mean, it still is, but it's not as effective. The thing that I want to clean up is this first step here. We need the first two terms of the Laurent expansion of this function here about z equals 1. And I think we can do that via partial fractions. Because I really don't want to do I don't want to properly get the Laurent expansion for this thing because it would be very painful. So yeah, to get through the problem, I just used Wolfram Alpha to get the coefficients that I need, which are these two bad boys. I can't imagine they're going to be a fan of me using Wolfram Alpha on the actual. Actually, let's not do that. on the uh, homework that I actually turn in, though, so we gotta get an actual justification for it. So what I really want is to split this fraction up into something like a over 5z minus 1 squared plus b over 5z minus 1 plus some function of z over z minus 1 squared. I mean, actually, no, I should just do regular partial fractions. That would be good enough. Because I don't really know what I was... Yeah. Wait. Oh, shoot. I was... what I want... It's about z equals 1. I forgot. So what I actually want are c and d. Oop. It's actually that's going to really bug me. No. A, B, C, D. This is completely pointless, but I can't handle my labeling not being like this. Okay. So I really want A and B. Those are the only two things that I actually care about here. So A is going to be multiplied by 5z minus 1 squared. B is going to be multiplied by z minus 1, 5z minus 1 squared. C is going to get a z minus 1 squared. D is going to get a 5z minus 1 and a z minus 1 squared. That's a little bit annoying. That's I lied. That's a lot of it annoying. Hey, Math Pond. Yeah, it's so much fun. Where this is coming from is I'm working on this problem up here, and in order to get a series solution for this ODE, it's actually going to be a Frobenius series, which is like a Taylor series, but the powers are rational instead of integers. Actually, I think they can even be complex in general. Given that, you need to get the Laurent series for basically this function here, a few of the coefficients at least, depending on how many terms you want. We need 2 terms here, so instead of getting the Laurent series for this thing directly, I'm hoping that partial fractions can just do the heavy lifting for me, because I really want these 2 things right here that I got from Wolfram Alpha. The rest of this I don't care about. There's quite a bit of algebra to do by hand, though. 25z squared minus 10az plus a. Cz squared minus 2cz plus c. Oh my god. We're going on to a second line. 25az squared minus 10az plus a. Okay, so we're going to get 25bz cubed. We're going to get... Ooh, okay, so where do all our squareds come from? We get a minus 10z squared. We get a plus 25z squared. No, a minus 25. So minus 35z squared. Anywhere else? No. Okay, how about our z terms? We get a 1z. We get a 10z. So 11z. And then for constants, it's just a minus 1. Oh, I forgot my b's. Okay. Lucas? Is that... Did you change your name? That is you. It has been some time. Hope you've been well. Get a 25dz. Is this the same math as before? No, it's not. Damn. Okay, so for squareds, we get a minus 10z squared. We get a minus 1. Um, 5z, 7z, and a minus 1. Okay, I did those right, because I really don't want to put any more work into it. Oh, is that your actual last name? Honestly, I never really thought that much about it. Oh my god, I'm actually going to do 4 equations for unknowns by hand. Let's see how they look. We only need A and B. We don't care about the rest. So from the squareds... Oh wait, actually I guess we have cubes. We have a 25b. We have a 25d equals 0. From the squareds, we have a 25a minus 35b plus c minus 11d. From the z's, we have a minus 10a. We have a plus 11b. That's not a b. That's a b. Minus 2c. And a plus 7d. Bruh. Wait, we actually have a 4. Okay, and for constants. A minus b plus c your d minus d equals minus 1. Okay. Kinda. I'm this is a homework question to solve this differential equations basically with approximations. And I used Wolfram Alpha to skip over doing a bunch of algebra, and I'm trying to go back through and do the algebra now because I'm not going to be able to cite Wolfram Alpha when I actually turn in my homework. So yeah, I'm doing some partial fractions. I just need to get 2 of these variables. The other 2 I don't care about, but I might need to... Oh my god, this is such a pain in the ass. There's not really a particular trick here. Okay, you know what? I am gonna Wolfram Alpha this, because I'm definitely, like, when it comes time to LaTeX up this homework, I'm not gonna LaTeX this part. So there's no point in doing it by hand this far. Oh, you can take... Wow, you can submit pictures to Wolfram Alpha now. That's kind of cool. Actually, can we try it? Oh, yeah, of course I have to pay for it. Good old Wolfram. I should be able to just slam another row, slam another column on this. One, two, three. Aaron, I have one doubt related to inequalities. TPT? 3a to the fourth plus b to the fourth minus 4a cubed b is greater than or equal to 0. I don't know what the TPT means, and is there a restriction on A and B? I don't understand the question. I know math one. I don't know why I thought it would be free. Rookie mistake right there. Oh, you know, I need another column. There we go. Okay. So we have 0, 25, 0, 25, 0. 25 minus 35, 1 minus 11, 0. Minus 10, minus 35, 1 minus 11. 0. No, 0. Wait. Oh, I lost my place. Ah! It was minus 10. It was 11. It was minus 2. It was 7. It was 4. There we go. 1, minus 1, 1, minus 1, minus 1. Okay. Just checking that I entered this right. Okay, yeah. Give me RREF. There we go. Well, that's not good. That doesn't match at all. Okay, we're in trouble. But what are A and B, Aaron? Are they real numbers? Over Wait, underleaf converts pics to LaTeX? That's pretty cool. I did not know about that. Guess what? I've been doing some personal algebra stuff again, trying to remake operators. Ooh, that, you know, I'm not surprised. I guess I could have guessed that. Hey Zach, input a bunch of that. Output a differential equation. I wish math were so simple. Me yelling at Wolfram? Yeah, I should open up Stephen Wolfram's stream and just give him a piece of my mind. Because, you know, why should a math tool be free? That would be a crime. Okay. I mean, Stephen, he does have an actual stream, Stephen Wolfram. I don't think he's streaming right now, because I don't remember seeing him live, but... Angry Don yelling at Wolfram Alpha meme? Yeah. Okay, so what I was hoping for... was... I was hoping that this minus 13 over 24 would match this 3 over 16. And this minus 7 over 12 would match this minus 7 over 32. It's annoyingly close. Shouldn't these... I must have made a mistake in the setup. I feel like this approach is fine. Well, yeah, but Aaron, what are A and B? Like real numbers, integers, complex numbers? What? Gotta have the bifocals and everything. Hey, famished. Big problem I've noticed is that operators, especially exponentiation and further, are not best defined. The pure operator is plus. I'm trying to rebuild multiplication or something else. A to the B is, I think that would be commutative. That would be a pretty wild thing to make work, Lucas. A to the B equals B to the A. Hey, JC. It's been a minute. Hope you've been well. Okay, A and B are real numbers. I don't know if I can do this, Aaron, but we can think about it. Yeah, I feel like there's gotta be at least like one example with real numbers where A to the B does equal B to the A. That's not trivial where A equals B. I can't immediately figure out what that number is though. I don't know. If A and B are real, then polar substitution might work, Ayush says. Well, just think about polynomials. Surely A and B, like, if there is a counterexample, it would be A and B being really small. I'm not really sure why this should be true. Do negative numbers? No. Negative numbers definitely work. The only thing that might not work are positives. Oh, you do, Ayush. Yeah. I like that. I bet that's the idea for this problem because that seems intentional that they set it up like that. Well, this is nice. Um, is it fact? I doubt it's factorable, right? I guess +1, -1, +3, -3 are the only possible candidates. Ooh, wait. X equals 1 is a root. Um, we need to show that both these roots, or that we need to show that all the roots of this thing are either complex or multiplicity 2, right? So they bounce. Um, Do you think I can solve an exercise using category theory for a Galois theory exercise? I'm feeling lazy. I'm sure you're asking me that ironically, because I feel like you should know better than to think I would have any idea about that. You know, I say don't let your dreams be dreams. If you think you can do it, you should do it. Or I guess maybe you're asking more about like permission. X-Fret. Hope you're doing well. I hope your studies are going well too. Differentiate the polynomial and find extreme points. That would be, you know, Ayush, that's way faster than my idea. Damn it. You okay, yeah, that's way better. If we can just show that the minima are positive or 0, that's enough. Oh yeah. Well, that means that I'm coming in third at best here, so. 12x cubed. Okay, yeah. So we get x squared. Guess, well, we can just divide the 12 out. Who cares? X minus 1 is equals 0, comma 1. Okay. Using only algebra? I mean, I guess this should still work then. Like, this still counts as algebra, right? Maybe they don't know calculus in this class. So this argument would, I mean, we might want to do a second derivative test or like a sign chart like X-Fred said, but this argument would work. It's a repeated root directly divided by x minus 1 squared. Ooh. It should be repeated, I agree. And actually, yeah, I guess... Okay, let's try that. I don't think I've ever divided by a quadratic. Maybe I have. I don't remember. I'm kind of curious to see what that would look like. Oh yes, I was thinking about synthetic division. I can never remember like how it works though. Yeah, I was gonna, I guess. Yeah, I guess you can see from that x or 1 is another 0 there. I kind of, this would be a way, like, better way to, like, I should have skipped this and just done this. So we have an x squared. We want to make a 3x to the 4th. So we're going to multiply by 3x squared. Plus 3x squared. Is that right? I think so. Minus 4 plus 6, positive 2. Minus 3x squared plus 0x plus 2x. Minus 3 plus 4 is x squared, minus 2x plus 1. Nice! You love to see it. That's even, like, there's less steps in this compared to that, too. It's nice. So we know it's like x minus 1 squared. Oh, and that factors. And as it should, I guess. synthetic division hurts my soul because it involves memorization. Oh wait, no, that's not factorable. That's actually even better though. That means the roots are complex. Yeah, I can never remember how to do synthetic division. It doesn't feel natural to me. Maybe that's why it's synthetic. I guess technically we should do the quadratic formula on that still though. Because what if they're irrational roots? Minus b plus or minus root b squared minus 4ac over 2a. 2 plus or minus 2i root 2 over 6. So the only thing you really need to know is that they're complex. So, we have one real root with multiplicity 2, which means that, I guess importantly, the leading coefficient is positive, which means, and the degree is even. So, off on the sides, we know it goes up to positive infinity. The only real root is x equals 1, and it's a double root, which means it has to bounce off that root. So it's going to look like a steeper version of a parabola, I guess. So I guess this would be the argument, Aaron. D less than 0? Yeah, that's a quicker way than doing the entire quadratic formula. Okay, Aaron, I hope this argument makes sense. Synthetic division is easier to divide it by linear factors. Yeah, I know. It's always weird. It's like you have to, if you do synthetic division, like you put a -1 there, and then you. Let me see if I can even remember how to do it. 3 minus 4. Or is it a 1? See, I already don't remember this part of how you set it up. And then for like the next stage, you bring the 3 down, and I think you multiply these and add down? I think I must have flipped the sign though. Okay, so yeah, I know it's faster. I always get scared about the sign of the number up here, and then whether you add or subtract or whatever. So that's why I don't like synthetic division. I just am always afraid of like messing up those two things. Once free, I mean, I guess that's fair, but how do you know which one is right? The one that gives 0? But what if you have like a whatever polynomial, like if they both work, you could get tricked. Like if you had something like that, but you know, it was like multiplied out. That's more of an edge case, but they both work, you can do both. Well, okay, fine. I'm prejudiced against synthetic division. All right, is that what you want to hear? I don't like it. I don't know. You make a good point. It's always I'm not gonna remember that though. Hey, Alkender, welcome. Yeah, I guess it's the actual root. It's not like it's always confusing because like x minus 1 corresponds to x equals 1. I don't know. Okay, so unless I hear anything else from Aaron, I'm gonna go back to doing this homework problem. So I was trying, so I already solved the actual problem, but I cheated and used Wolfram Alpha for this first step, where I need to get the Laurent, the first two coefficients of the Laurent expansion for this function here. I don't want to actually get them though, because that sounds very painful. And so my idea for a workaround was to do partial fractions, so I can get these two coefficients here. Actually, you know, but the issue is when I think I made a mistake with the partial fractions because the coefficients that I got didn't match up. I should make Wolfram Alpha do partial fractions to make sure this approach actually works. Sounds good, Aaron. Thank you. 4z minus 1. And hey, BR Gaming, you don't think they're related? I feel like they should. Like I feel like that this has to work because the rest of the function will be analytic at z equals 1. So there's no way it's going to contribute like a z minus 1 to the negative 2. Kim, thank you so much for the raid, Kim. Welcome in, nerds, fellow nerds. Metallic Medlight, hello, welcome. Kim, how's your stream? I hope it went well. For people who are here on my end, please check out Kim. She has a fun stream. She talks about space. She plays games, all that good stuff. Fellow grad student too. Ed Sheeran with a buzz cut. Yep, that's me. I mean, I imagine if you're here, you're probably a nerd. Finish with a math video. Ooh, what kind of math? Oh, see, this partial fraction, it does give the right thing. And if you'd rather rate and run, please do, like always. So I just did the partial fractions wrong. For people who are coming in here, I'm a master's student working on master's in applied math, and this is a homework problem to basically get an approximate solution for this differential equation here. And I already answered it, but there's one step that I just kind of phoned it in and used Wolfram Alpha to cheat and do a lot of algebra for me. And so I'm trying to go back and clean that up and get actual work for it, because I can't cite Wolfram Alpha on my homework. Video on Hilbert spaces. Ooh. You haven't taken linear algebra, so you didn't gain a lot from it? That's fair. I don't know what Hilbert spaces are for myself. I've encountered like things that make references to them or that rely on them, but I haven't been able to actually learn what they are yet. Get the white screen away from me. My 10-hour daily screen exposure eyes hurt. I am a light mode enjoyer. I'm sorry. I did try to put my Wolfram Alpha in dark mode. It kept going not in dark mode though. The only reason I have like this program right here in dark mode is because I feel like people like freak out if I use light mode. Hey, Boston. Silver spaces mentioned. Oh, you know them, Papadoria? Also, yeah, I didn't say hi to you, Papadoria, but hi. Yeah, sure, Xfret. You got fun problems. I think I must have messed up some of the multiplication in here. There's a story. Okay. Based on studying integral transforms like Fourier and Laplace and Mellon. Ooh. Yeah, I think the last place I saw them mentioned is when I was looking into wavelets, which are like a Fourier transform, but more like localized. Um. Ooh, okay, this is gonna be a fun setup to a problem. I can already imagine making a vector for the state of the light bulbs, or the light switches. Okay, well, I'm gonna screenshot some of this work here, and I'm gonna, while Expert types this out, I'm gonna start. I'm gonna blind all the dark mode users, and I'm gonna check some of this multiplication that I did. (25z cubed minus 35z squared plus 11z minus 1). That's fine. Then what about this? 5z. Oh, I can't do math. What a stupid mistake. I had a 25 here. The culprit is right here, officer. I come back over here. Wait, screen alert, yep. Which 25 do I delete? Or that one? That gives me the correct answer. Okay, so partial fraction does work. Because... And thank God it does, because I do not want to go to the general formula for the coefficient of a Laurent series. Okay. Let's start reading Xfret's question. By the way, linear algebra is pretty great. We stand linear algebra around here. You're okay if they're functions, but not infinite. Ooh, thanks for the 3 streak, Vasen. Let's find out if it makes sense. I still need to actually read this. Okay. Poldor is saying to Dessen, imagine if those vectors are not links, but the functions or sequences. Hilbert and Reese will tell you all about it. Okay. Well, it's here now. Your second room with many light bulbs with switches next to them. All the light bulbs are initially off. Oh, the song requests aren't going to actually play. All the light bulbs are initially off. You want them to turn them all on. Light switches are connected by wires. Turn a switch on next to light bulb, say light bulb A. It toggles all the adjacent ones. So B and C are adjacent. String A will toggle B and C. Turn this. There were 5 light bulbs in a line in alphabetical order. You could toggle B, also toggling A and C, and toggle E. Okay, yes, this makes sense. I'm curious to listen to that song though. Maybe I'll bring up the queue. Where? Oh yeah, it's through Nightbot. Song requests. Okay, this is Destin's song. Oop, too loud. I'm already enjoying this vibe. Okay. Problem is, you get to assume that there's no way to choose a non-empty collection of light bulbs. And toggle each so they all get to be off again. There's no way to choose a non-empty collection of light bulbs. Roxra, hey! Hope you're doing well. That's a good question. At most, 2.5 hours more. I've got a hot date tonight with some fried chicken. I'm not lying. Actually, I'm gonna get some fried chicken. But yeah, I'm gonna have a hard cut up in 2.5 hours. It's possible I would end it earlier. I don't think I will though. Okay, yeah, no, that's definitely fine. It's a good song. I'm gonna add it to my French playlist. One second. There we go. Okay, so I get to assume there is no way to choose a non-empty collection of light bulbs and toggle each so they all get to be off again. Sure, there is a way to toggle them all on. If you can turn them all on, you can turn them all off, can't you? I don't understand what the problem is. No way to choose a non... They all start off. They all start off, so if you don't toggle any, they'll end up off. There's no way to choose multiple light bulbs to toggle them. Oh! Okay, so... Provided... So, we're assuming there's no way that you could... Like, there's no magical sequence, where you only turn light bulbs on, but they somehow all end up off. And that makes sense, I think. Okay, yeah. Okay. I understand what Liz is saying now. I'm not sure, Papadoria. Sure there's no way to toggle them all. Sure there is a way to toggle them all on. I assume as we're showing this, we would need that assumption somewhere along the way. Like, maybe we'll get 2 possible results and we need to show that one of them is impossible. Makes it significantly easier? Okay. Aaron's putting an idea in chat. You could do x of I is equal to x of I minus 1 plus x of j. Oh, this is loud. Okay, we're going back to my playlist. Mod 2. Minus 1 status of the ith pulled previously. Maybe something like that, Aaron. Curious to figure out how it's related. And so we do have a hint that this is a linear algebra problem. And so let's just start with 3 by 3. It's like, maybe, do we want to make sure that represents the possible consequences of our actions? And the vector we multiply by would be our chosen action. So if we say toggle switch B. Oh, it's a knockoff of an IMO problem? Well, I'm glad it's a knockoff because I wouldn't want to do a full IMO problem. If we toggle switch A, we also toggle B. If we toggle B, we toggle all 3. Hey, Sockno. We toggle C. Oops. So this would be like a triple diagonal matrix. And we want to show... I mean, honestly, we can just say X, Y, Z. We basically want to show like 1, 1, 1 is always in the column space, right? And we're assuming, oh, and also, so I think what this assumption gives us is it's a full rank matrix, I guess, in this context. I don't know. Oh yeah. I also was a problem in an Eastern European math contest after I made it. Oh, funny. How did you know that? Do you know all the IMO problems? That's what Aaron said in the YouTube chat. I definitely don't know IMO problems. I'm able to get back to 0 sounds like linear independence. It does, Floppy, yeah. Hey, Skirtle. Yeah, and so I was just wondering, we're like, even if we find a solution to this, like this is just a 3 by 3, like this wouldn't be the full proof. We need to do this for n dimensions. We need to verify that X, Y, and Z are 0 or 1. Don't be afraid to take that big step. Ooh, that's a good fortune. You know what, Skirtle? I actually, I'm gonna be getting fried chicken from this place after I turn the stream off today. And I guess the place I'm going to is like Filipino inspired, and they actually have pancit on the menu, but it looked kind of gross, so I didn't actually get it. But I'm like, oh hey, Skirtle told me about pancit. Generalized Kramer's rule? Oh, maybe. This is Palab. Oh, I don't know. I think they just called it pancit. I'll probably, if I were to try it, I would get it from like a, not a fried chicken place though. Jake loves pancits, that tells you it's shit. Hey, the HD. Determinant of the matrix must be 1. Oh, is that true when like everything is 0s or 1s? Ooh, could you Could you, like... Would it be way easier to calculate it if you do it in, like, integers mod 2? I wonder if it's really quick in that context. I'm just going to do good old-fashioned row reductions on my example here, because I think it'll be pretty quick. Just to get an idea of, like, because I'm interested in what the XYZ is going to be. Zero, zero, 1, 0. 0, 1, 1, 1. Permute. I mean, I'll permute at the end. Zero, 1, 0. Ooh. Actually, well, this is a good thing if we're getting free variables, right? Because that means we can find the type of solution that we want. Maybe. So from this we're getting, I guess I'll call it C is always 0. And then A plus B is 1. That's kind of funny. I didn't remember how that sounds like me. Oh. I think I did this step terribly wrong. This makes so much more sense. Okay, no, this gets the exact right thing. Because now C equals 0, B equals 1, A equals 0. And that's the exact solution that I would expect for three switches. Okay, cool. So this matrix idea seems to work, at least for this small example. I found a way to make exponents work rather ChatGPT, which immediately makes it suspicious. I would be suspicious of that, yeah. Okay, so if we want to be more general, we're gonna have a tri-diagonal matrix. This I'm not very well lined up here. But something like this is what I'm trying to... Wait. Wow. Be more like that, I think. So X will be our action. Okay. In this new exponential, it's possible to interchange them. So A to the B equals B to the A, but it's a bit more difficult. Oh. Okay, that seems like it would work, I guess. Yeah, you're gonna leave behind a bunch of other stuff with exponents, but that would get you commutativity. Uh, ooh, associative is a good question. It might not be. Well, wait, what is association? If we have A to the B to the C? Yeah, that's what we would check for associativity. So you want to check that and that. Wait, I did the same thing twice. There we go. Uh, this is hard to look at. I don't know how to do this. Because I guess it would be A to the B, B to the A to the C times C to the A to the B, B to the like that maybe? A to the B to the C, B to the C, or C to the B, B to the C, C to the B to the A. I guess it's not associative. Mayan? You have your exam starting for Monday? Good luck. Or Maya, maybe, yeah. Plug in random things and hope. Oh, that's true, yeah. Um, I feel like I feel like theoretically this should have an easy inverse to compute. Like, would that be our strategy here? Oh, did it, Leo? I didn't even get a pop-up for that. Um, shadow bans messages? Oh, that's weird. Um, I mean, I theoretically you could probably just do row operations and just be careful about maintaining the patterns here. Aaron, that one looks a little beyond me. I don't think I'm gonna know how to do that one. Oh, I did see that. It didn't mean that much to me, though. What is an arbitrary graph? Or I know that, like, matrices have a connection with graphs. Might be back later? Alright, sounds good. The way they're connected isn't necessarily in a line. Huh. Is a random graph the same thing? Probably not. Oh, it's just a graph. Oh, okay. Sorry, I thought it was like a special thing. Um, Leo, this is the question here. Yeah, Aaron, I think I'm good on that. I'm sorry. And HD, yeah, we can talk about that. Let me, Leo, if you want to read the problem, take a screenshot of it or something, or I don't know, but I'm gonna scroll down in a second here. You're on YouTube. You can just rewind the recording. Oh, true, yeah. Let me quickly address HD. So you're asking about 5 over 6 times 6 over 8. Or yeah, like I know what you mean. I should probably just replace that as a thing that I showed to people if they ask what the question is. Okay, so there's two ways that we can think about this problem. The way that'll work for any time you have two fractions being multiplied together. Sorry, let me just get that off the screen so it's not distracting. Is when you have two fractions multiplied, you can multiply across the top and multiply across the bottom. So in this case, 5 times 6 is 30, and 6 times 8 is 48. And I'm going to show you an easier way of doing this in a second. And then they're going to want you to simplify this fraction usually, like, because these actually have common factors. They just have one. 2 goes into both of these numbers. So we can divide each of these by 2. So 15 becomes 30. 48 becomes 24. Oh, and sneaky. These both have 3 that go into them still. So we can cancel again to get 5 over 8. Okay, and so that's the long way of doing it, but it'll always work for any two fractions that you have here. The quicker way of doing it, that doesn't always work, but it often does, is you're allowed to cancel things before you multiply. So if I have a 6 on top and a 6 on the bottom, we can just immediately cancel those two things out and get 5 over 8. It wouldn't save you as much time, but it would also be valid to do a cancellation with the 6 and the 8, because 2 goes into both of them, so you could say that's 3 and that's 4. And I guess you could then do a cancellation with this 3 and this 6. This is, like, you know, not the best way of doing it, but this is also, like, possible. So yeah, I hope that makes sense, the HD. This would definitely be the way that I would do it personally, but if you're just learning how to work with fraction, and you're not all that comfortable with it, this is, like, maybe the way to start off with. So yeah, I don't know much about graph theory, so I'm not sure like what the graph interpretation of this would give us, but like if I were to draw a graph, A would be connected to B. I guess it's a back and forth. I guess it's not directional, right? B would be connected to, well, A and, oh, it's just going to be a line. Sure. I don't know what you do with this graph, though. I was a little confused by that, too, Leo. I should maybe have shown you the different version that XFret posted for the problem statement. That's a little bit simpler. Oop. 1 second. This is a lot shorter version of the problem. So basically, like, all the light bulbs start off, and you're assuming there's no way that you can toggle a bunch of switches on, and they somehow become off. So, like, if you had just two light switches, A and B, you could toggle both A and B, and they would end up being off. B connected to A, C, and D. Oh! I thought it was only adjacent ones. That changes things a lot. And, Roxra? They are important. So let me answer HD's question. Sorry, because I'm juggling I guess a few questions now. I want to make sure that I have time for everyone though, because I mentioned an expert's question. I want to talk to you about calculus Roxra, and then I want to know about HD with theirs too. So let me start with juggling me alone requires like one. It does. I love it though. XFred, please don't stop. And so, Roxy, I'll talk more about second derivatives in a minute. HD. So coordinates on Cartesian plane. This is kind of like the traditional way of drawing a Cartesian plane with x and y axes. And these tick marks should be evenly spaced, but I don't have that good of an eye. So each of these tick marks represents like a coordinate, like I guess a spacing of 1. So along the x, this is +1, +2, 3, 4. We can go to negatives. And same thing with the y's. 1, 2, 3, -1, -2, -3. So if we want to locate the point, say 3, -2, that's a negative. This is the x and this is the y. So you go 3 to the right on x and then 2 down on the y, and so your point is right here. And this is arbitrary, like there's no reason we have to label things like this, but this is the way that you start off. You're allowed to have like a half as well. There's no reason you have to stick to just like one or two. You can have 1.5 or a third, whatever. So yeah, let me know if that makes sense to you, the HD. And then Roxra, second derivatives are important because they tell you about the concavity of the function. So yeah, and I'm trying to figure out how to express what that means. I really like thinking about derivatives in terms of like position, velocity, and acceleration. So like if your position is f of x, your velocity is f prime of x, and your acceleration is f double prime. And so your second derivative basically tells you what your acceleration is like. So if you're if we're going to make a graph of our position, and x is, I guess maybe we could call it t for time, but it's not super important. Let's imagine like you're driving in your car and you're coming up to a red light, so you have to slow down and stop. Your velocity is positive, like you're still moving forward. So like we're gonna have a positive slope here, but if you're slowing down, you're kind of like leveling off. So exactly, yeah. So it kind of tells you like, it tells you how like it tells you how your first derivative is changing, which is a little bit of a stupid way to explain it, but it's true. The slopes of the tangent lines here are leveling off. Yeah, it is weird. And so if you were to completely slow down, come to a stop, and then reverse your car, the graph of your position would end up looking something like this. Oh, Joseph, that's a late first. Holy crap. Congratulations, though. And so this function looks like an upside down bowl. We say it's concave down, or I think sometimes they say like convex and concave. I don't remember which one is which, though. The way I was taught is to say this is concave down when it's an upside down bowl. And if you have a bowl that's right side up, it's concave up. Those are used in shapes, yeah. You can have a convex shape or a concave shape. If you're studying hard, but stuff is getting harder. Yeah. And there's probably a reason for that I don't know. Not usually, no. Because like if you have yeah, it's just exactly that there. You just take your first derivative and then you take the derivative of that. So if you have x cubed plus 2x, you can take your first derivative, 3x squared plus 2, and then you just take the derivative of that, just the same way that we did the first one. So 6x. No worries. So yeah, if we put to keep the calc questions coming, I am going to come back to XFRET's question for a bit, though. Just trying to split my time somewhat evenly between people. So, okay, so the issue is that the connections can be arbitrary. That's what I'm not accounting for here. and Leo was talking in chat and seems to have gotten the idea. The adjacency matrix is injective. There's an F2 linear map. Switches to light. Shows there exactly one configuration to turn them all on. Okay, those are words that I don't understand. Potentials on directed acrylic graphs. Acyclic graphs. Acrylic? I don't want any of those oil graphs. What would you recommend? I haven't examined in 2 months. Understand concepts in depth, proof of related formulas, understand the definition, learn the formulas, solve a ton of good questions. When time is limited, probably focus on problem solving, in my opinion. Like, if you think, depending on how you think, like, maybe you want to do the first one, but personally, like, I focus on problem solving because that's more directly related. And it usually helps me understand the concepts as I do it too. Acrylic graph sounds nice, yeah. So yeah, it's well, I guess with this problem I'm just kind of stuck now because we need to be able to describe how this arbitrary matrix of 0 and 1 should look. Because there's certain configurations of this that would be invalid for this problem, I think. Is that true? Maybe not. Well, I guess there would be. Like, you can't have all zeros. Or else that'd be not a very interesting problem, at least. You give up? Now you thought of something else again? I feel like you never have a shortage of ideas, Lucas. Can't get all zeros since each switch at least toggles the bulb next to it. All right, Lucas, cook. Wait, we are guaranteed this. What, like, are we guaranteed they have to toggle the ones next to it, but maybe also other ones? Oh, okay. So in this, like, arbitrary matrix I made here, we could basically replace any of these zeros with ones, and the result should still hold. Okay. Are proofs even relevant in maths as long as you are applying it in problems? I mean, depending on who you ask, like, math is all proofs. That's all math is. I prefer, like, the applications of math, but, like, math is all about proofs. If you're not proving things, then you're applying it in some way, usually. Do you think I could skip implicits and inverses for now and then come back to them? Are they important in that I'll see them in more complex differentiation? The inverse one doesn't usually come up all that much. Implicit is... It depends on the structure of the class. They usually like to ask a lot about implicit differentiation, though, in my experience. And knowing implicit differentiation does give you some shortcuts to make certain types of derivatives easier to calculate. This is like self-study, you mean? Oh, okay. I would not skip implicits. Inverses, like, I don't think those are a big topic, but I mean, you could skip implicits if you really want to, but it's good to know those, and they're not that bad. Also, like, the matrix is symmetric since it's an undirected root graph. Oh, yeah, it is symmetric. True. No one's learning the proofs, and also there's no end to solving great problems. Maintaining a balance is pretty tough. Yeah, I mean, you're never done with math. At least if you believe Gödel. There's always another thing to do. Sounds good, Roxra. Oh yeah, Zach. I think Roxra have been talking about just like learning calculus for the first time though, so I think they're talking about just like implicit differentiation and whatever that formula is for the derivative of an inverse function. Multivariable analysis is it's the theory of calculus with multiple variables. So it's all about like the proofs behind calculus. And so what you're learning right now is single variable calculus, but eventually, if you keep going, you'll learn calculus in three dimensions and more. It's honestly it's awesome. It's a really cool topic in my opinion. Oh, I'm sorry, Aaron. I mean, you should choose whatever makes you happy. Math is definitely not easy, but neither is computer science. Yeah, Zach, I saw you with your with your Torision counter this morning. GP Bear, woo? What are you wooing about? Maybe you like it? I hope you will. I love it. Jacobians, etc. Coordinate transformations. Well, yeah. I know it's torsion. I was debating whether I was gonna stop lurking and say something until Stooky did. So, hey, Slim, you changed your color, didn't you? You're blue now, and I think you weren't blue before. Um, I guess this matrix, it's symmetric. We're guaranteed to have ones on these three diagonals, and we may or may not have ones on the other diagonals. Oh yeah, that's a little bit disappointing. I was hoping for more, but I think you guys did switch topics. Oh, yeah. Blame the cat. I don't remember what color you were, to be honest. So maybe it's just me making things up. Um. So yeah, we're working a problem from the extra. Just kind of put in here for fun. This problem statement is a little bit long, but um, you're not sure about it, Lucas? All right. Basically, you have an arbitrary number of light bulbs in a row. Um, you want to toggle all the light switch or all the light bulbs on. If you toggle one switch, you're guaranteed to toggle the switches right next, or the light bulbs next to it also, not the switches. You may also toggle some light bulbs that are farther away. and you want to show there's always a way to toggle all of them on, and this assumption is apparently unnecessary but helps simplify the answer or the solution. Yeah, it's a little hard to like describe the like how they're connected, because I didn't understand it for a while, but like you always do the, I guess it depends like just how we're defining adjacent. I don't know. Yeah, and so apparently linear algebra can help with this. I've done it for like a simple case, and I got something that makes sense. And this is like maybe a simpler way of stating the problem too. There's a nice induction or some degree trick if you want to remove that the assumption. I wouldn't know. You just assume they're on a grid. That's probably general enough. Okay. Oh, also Jed. Sorry, I didn't address that. 40 streak. Not bad. Lordy, lordy. Thank you. Induction to standard way. Okay. You can also love yourself in spite of all your faults. I don't know where that's coming from, but okay. That's true. Without the condition, yeah. I'm just going to say that I want to make an operator that changes your numbers number line. So 1 triangle 1 equals I. I think operators are functions? Question mark? An operator is a function that assigns 2 numbers to 1 number, I think. So the difference might not be important. Oh, that's I've had people on YouTube say that their stream randomly lags behind. I don't know why. As far as I know, I can't control anything with that. You understand assumption 2. Toggle to A, B, D, E. When do they all turn off again? Okay, so the example might not be quite right, but actually, wait. So maybe I'm still not understanding. If we toggled C, I thought that it would have to toggle B and D, but then it could also do A. Wait, oh no, it did. I'm sorry. I wasn't looking at the progression. Never mind. Okay. Wait, no. Now I'm still confused. We toggled B, so it turns all 3 of these on, and then if we toggle C. Okay, for this adjacency. Okay, but we could have other adjacencies, is what we have to account for. Like, okay, yeah. We could have C be adjacent to all 4 of these. 4. Or all 5 even, I guess, but. Which was like a different world for me, the way things work there. It's different, but I like it more than YouTube personally. Like the product rule and chain rule, those are both helpful. Yeah, okay, good. Hating the quotient rule is the right way to feel about it. Quotient rule is terrible. Do you know the mnemonic to remember it? E is like one of the best. E to the X is one of the best functions ever. Quotient rule is very divisive. It's true. For the quotient rule, the way that I remember it is if you have a function high divided by low, and you need to take the derivative of it, it's high d low, d meaning derivative, minus low d high. That's a, and then it's just over, wait, high d low, or is it low d high? Do I, did this, damn it. Wait, high, not, the mnemonic isn't working now that I'm actually thinking about it. Multiply by -1 in your Gucci. Dang it. Low D high. Low D high. Dang it. I got it backwards. Low D high minus high D low. Okay, that's the first time I've ever messed up that mnemonic though. And of course it's the one time where I'm trying to teach someone how to do the quotient rule. And then the low square, you just have to remember that I don't have the trick for that. Yeah, Roxor, the way that you wrote it is good too. Quotient rule mnemonic count of 1. True. Alejandro, thank you so much for the raid. Gracias. Genominio, hello, welcome. For those who don't know, Alejandro is a fellow math streamer, Spanish language. So if you're interested in that, please do check him out. Cool dude. Go over there and learn Spanish. I hope your stream was good. I appreciate the raid. You don't speak Spanish or math. Using partial instead of quotient rule, treating the function. Yeah, that's another way of doing it, Ayush. Yeah, I got it backwards. So yeah, working on a problem about, it's from xfret, who is who's asking about this problem with light bulbs. And we have a bunch of light bulbs that are connected in some arbitrary way, and we're trying to show there's always a way to toggle all of them on if one light switch might toggle multiple at once. Hi, Alejandro. I appreciate it. It's good to see you too. Thank you, thank you. Looking for that magical light bulb aha to solve it. True. Let's say you have n light bulbs that you think of their state as an n-dimensional vector with binary coefficients. Right? What you want to check is that the vectors given by having 3 consecutive ones forms a basis. You have n light bulbs. You want to check is the vectors given by having 3 consecutive ones form a basis. I'm not sure what that last sentence means. So similar to the lights off game. You cannot get every state from every state. Yeah, if they were all in a row, like A, B, C, D, E, I think I could figure out something with row operations. It wouldn't be the best argument ever, but I think I could come up with some type of solution. When things are a little bit arbitrary, I'm not quite sure yet. We did get a hint that this like adjacency matrix would have to be symmetric because there's no like directionality here. We know there'd be ones on the diagonal. Suppose you have N light bulbs. Are you going to sell them? Might be tough because they're probably incandescent, not LED. Yeah, true. There's a light top solver. Not sure that's a grid version you're thinking of. Just construct a solution for the light bulbs in a row. Oh, okay. Yeah, and so I think this like helpful assumption that XFret gave is basically promising us that. Oh, and if they're full rank, then we can always get to any vector. Like it spans is the point. Do we need to be concerned that this vector we're multiplying by, like, do we need to show it's going to be zeros and ones though? That might be important. Like, and not just some arbitrary real number. I think we would need to do that. Feeling my own math teacher doesn't remember derivatives to help me. Oh no, she isn't teaching calc, but still I want help. What math class are you actually in then? You work mod 2 and work same mod 2, and you just can't divide by 2. Algebra 2? Oh wow, Rox. So yeah, you're ahead of the curve. That's awesome though. But yeah, I can understand why your teacher might not be able to help you. That's why you work in F2. Basically, odd numbers are 1, even numbers are 0. Music's a little loud. Song is kind of weird too. I'm gonna skip it. Yeah, so I guess do we what am I trying to say? I don't know what I'm trying to say. Well, I guess we need to worry about other arrangements of this matrix also. I mean, do we actually have to? If we do have this assumption, can we just say that we're guaranteed to have a full rank matrix in the field F2? And since it's full rank, the vector of ones has to be in the span. Do you think you could? Do you think I could win gold in the men's figure skating? Definitely, easily. Trying to say it is more important to respect yourself and others just by virtue of their humanity than by reasoning to yourself. I don't know what you're on about with there, Leo. Should I do C solution to tough problems? Try to understand the idea. It's usually better to solve things for yourself, Aaron. It can be helpful to look at solutions, like, it's always helpful to try it for yourself first, even if you end up looking at the solution later. Like, there's no substitute for doing things for yourself. Trying to help with the problem. Fair enough. Um, yeah, I don't. I guess maybe I feels like this is too simple, but if I were to make an argument for an actual solution here, let A be or let I guess the network of connections between light bulbs be represented by a graph, which can, I know this it might be a little, I don't know if we need to go through this graph detour, but matrix A. I don't think this part's important, but so A is symmetric and has ones on the diagonal. I guess in F2. By the assumption A is full rank, the desired state of the light bulbs being turned on can be represented by the vector 1, 1. No zeros. 1. Since A is full rank, this vector must be in the column space. So, like, is this just the answer here? Oh, okay. I was making it harder than it had to be then. Should argue why A is full rank. I guess you're a harsher grader. Oh yeah, because problem is you get to assume. Oh yeah, so okay. That's fair. We assumption A is full rank. Yeah, you guys are grading too easy here. We'll explain it. I've been thinking about how people like the big E figure out all until I realized they didn't have video games. Big E like Euler figured all out, or Biggie Smalls. Yeah, yeah. They did have a lot less distractions. That's true. Confused by those puzzles when I was younger. It's fun to realize you can do with linear algebra. Yeah. Assumption A is full rank. It's full rank because the null space is A the dimension of the null space of A is 0. Like, it's only like the trivial vector. So A is full rank. I I know like what the I know why this is true. I just am having trouble putting it into words. The light bulbs all being turned off corresponds to the vector 0, 0, 0. And the assumption means that there is some non-trivial vector, or like it means there can't be a non-trivial vector that gives you this. The assumption says there is no non-trivial vector that A times some vector X. There's no non-trivial vector X such that AX equals 0. There we go. rank nullity. Yeah. Raven. O to the 2i pi. Ode to the 2i pi. Raven, so we just answered a question about light bulbs, I guess. Turns out, or like a little like puzzle question. Basically, if you have a bunch of light bulbs, each of them has a switch, but those switches are connected in some arbitrary way. So like the light switch for C, it always toggles C, but it could also toggle other light bulbs too. And so given a setup like that, you have to show there's always a way to toggle them on. And it's apparently not necessary, but we're allowed to assume, which makes this problem a lot easier, that there's no way to there's no way to flip switches and have them all result in being off. You hate those puzzle games? It's really, the answer isn't all that hard, but it took me a while to understand the question and to like wrap my head around what's actually happening. They would hate my homework problem solutions. I'm very brief. Yeah. I finally had the light bulb moment. I did. Ugh. I try to be brief, and then like in one of my classes, the professor announced like, show all of your work, and I'm really annoyed at that because I feel like asking me to see my algebra as a master's student just feels like rude. But apparently, and that's in one of my classes, they want to see the algebra. Making another cup of coffee. Coffee is like math juice. We're trying to prove such a configuration exists? Yeah, Jed. And so what I typed up in the middle of the screen here is a linear algebra like proof for that. There's probably like another way of doing it too. From course before, if they don't need grades, I generally don't give them. Say what is wrong or right, scores don't matter. Yeah, I like that. Sounds good, Leo. Enjoy your game. It's your birthday in 6 months. Can you get VIP? Oh, it's your half birthday then, Raven. I don't know. If you guess the magic number or get 25,000 points or whatever. Yeah, I mean, so to be fair, it is a it's one of those classes where it's like there's undergrads and grads in the same class. But like oh, you're off 2x, Brett? All right. Thanks for hanging out. So there are undergrads in it too, but like she didn't make an exception for grads or anything. So I don't know. It feels kind of risky. I really went back in and like latexed up all my algebra too, and my homework got way longer. And Jed, yeah, if If A, B, then B, A. Prove everything from CFC SAC. 2 plus 2 equals 7. Okay, but yeah, if you're off expert, I appreciate the problem, and for you saying hi. One day. Okay. If anyone else has a question or something they want to talk about, let me know. Otherwise, I'm going to go back to my homework. It's a fun one. Linear algebra is pretty pog. If I do say so myself. Okay, so I think I've shorted up my work for this problem in the way that I wanted to. I think I'm satisfied with number 2. So we can move on to a different problem. I do want a cup of coffee. I've already had one today, and it's definitely way too late to drink another. But the urge is there. All this stuff here is me being in office hours and hastily typing out things that the TA is saying. By the way, I don't know if I want to. The number 1 is really tedious. Would I rather never have coffee again or never do math again? That's a really tough one. Never doing math again would make it, like, does that mean I can't do my taxes? That would be, like, kind of impractical. If I literally can't do any sort of math. Or I can't, I don't know how much to tip if I eat at a restaurant. Or I don't know how much I'm about to spend when I go grocery shopping. Baking would be a challenge too. Oh, okay, I can do it on a calculator? Okay, okay. That's honestly, it's really tough. I would lean towards not doing math, to be honest. If I'm still allowed to use a calculator. So I really like coffee. I don't know. It's really hard to choose because, like, the things that I really like in math and why are math, coffee, video games, and music. Like, those are all things I like turn to if I want to feel happy. Recipe calls for 2/3 a cup. I'm making half a recipe. I mean, I don't know. You got a new blend you forgot to try? Oh yeah. You give up coffee in a heartbeat. Ooh. Oh, tea. That is a good point, Famish. That there's a whole world for tea too. Survive on water? Oh yeah, yeah. Besides, like the only thing I really drink are coffee, water, and I guess like alcohol drinks. But like throughout the day, I'm basically just drinking water. Place an order for a .333 measuring cup. It probably exists, at least as a meme. I mean, you can't. I know that. Mm. The idea of a repeating decimal corresponding to a physical measurement is kind of disturbing to me because like a repeating decimal never ends, but the cup has to physically end. And it's like, what does that even mean? I don't know. These are kind of things that keep me up at night. Do I like I turned Australian for a second. Do I like coffee liqueur? I don't know if I've actually had any. I've had Bailey's in coffee, and that's all right. I've also had just like a regular like Irish coffee, which is whiskey and coffee. Um, it's not bad. I guess I'd say it's not my favorite, but yeah. I don't think I want to deal with number one right now. Number one's a really frustrating problem. Rigid, I don't know why my J paper is not good. I prepared a lot. I have a second chance in April. I'm sorry to hear that, Rigid. The JE looks really tough. Yeah, when it comes to stuff like that, all you can do is try your best. And even if it doesn't work out, you'll find another path somewhere. But in the meantime, to prepare for your next chance in April, just try to think about the things that you're the weakest on and work on those. Just go for more practice problems and just try and shore up where you think you're not as strong. And just give it your best shot and don't beat yourself up if you don't make it still. It's a really competitive exam, it sounds like. Oh yeah, I want to restart number 3 from scratch, actually. What is this? They're fraction measuring cups. I actually these are kind of cool for teaching kids fractions. So you have the full 1 cup and then a half cup, a third cup, and a quarter cup. I kind of like these. Unironically. The second pick? Yeah. Good luck, Bridget. Oh, there's a little tower. That I like the tower too. You have a half, a third, a fourth, a fifth, a sixth, an eighth, a 10th, a 12th. Wow. This is a little bit extra. Give me a 12th of a cup of flour, please. You know, yeah, I can use these for cooking. Um I feel like you could use these to talk about sequences too, somehow. A 12th cup is 4 teaspoons. That's good to know. Wow, all that for 15 bucks. It's me checking the quotient rule. 3 teaspoons per tablespoon. 8 tablespoons is half a cup. Oh yeah, I know that from butter too. 48 teaspoons per cup. Oh yeah, Raven. The 3 teaspoons to tablespoons thing, I did not know. I couldn't have told you that offhand. I know, Ayush. I'm a little bit disappointed there's no 7th or 9th. I did notice I skipped over those too. You get American recipes, you lose your mind. Yeah, it is better to just weigh things and use grams. I think it is more stressful to weigh things to me. Because if I'm off by even a little bit, I freak out about it. Whereas with volumetric measurements, I'm like, oh, that's like about right. Um, but yeah, even then, I've heard that like American recipes and European recipes don't always translate to each other because our butter is just different. At least when it comes to baking. Welcome back, Roxra. There's no one else asking questions, so if you have any more questions, I'm all yours. Just did approximately, yeah. Because like with volume measurements, it's just never really going to be exact. It's v of x. I bet that I could teach you implicit differentiation and it wouldn't be that bad. But that's up to you. I'm happy to talk about whatever you want to talk about. About learning a steady upwards curve. I would find something with structure to study off of. Have I already told you about like Paul's online notes and MIT OpenCourseWare? No? Oh, okay. We need to have a talk then. So I don't know if I would use that as like a primary source for doing all your calculus learning, but Paul's online notes, I love this site. It's a great reference for everything you encounter in a normal calculus class. Khan Academy? Okay, so yeah, I personally haven't been a big fan of Khan Academy when I've tried it, but if it works for you, there's nothing wrong with it. Yeah, this is like a really good like supplemental resource, I would say. So like what I really like about this website is they have a lot of example problems with solutions, and the example problems are really well chosen. And it's a very like practical explanation too. He does not go into the theory, which for an introduction to calculus I think is kind of nice. And so I think Khan Academy is pretty structured, and so you probably are not going to go wrong sticking with that. Yeah, the site is really nice. Like this covers everything that you're gonna want, and there's even more. Like if you look in practice problems, in the tab for any of these sections, there's even more with solutions. This one, wow, it has 32. So there's no shortage of practice problems here. The assignment problems also exist. I don't think they have solutions though. You could use Wolfram Alpha to get the solutions though. Oh, interesting. Famished. I use like, if you mean like chain rule, yeah. These are commonly taught in university. I did not ever play Dr. Mario, no. Pause all my notes? I doubt this would be blocked on your school computer. I would hope not. And if you're ever looking for an alternative to Khan Academy, MIT OpenCourseWare is a good one. So you can like search calculus. I see you saying wait, but I'm going to keep on going. Yeah, sure. I'm just gonna make this one point about MIT OpenCourseWare, and then I'll talk about that. And see, it looks like Fam's just talking about OSSU that uses this too, but it's like they're gonna have a few things about calculus, I think, but just choosing this one looks like the good introduction. Where is this gonna take me? Oh, this isn't common. This is kind of crappy, honestly. Usually they just give you everything right on this page. Yeah, okay, so like this one instead, they even provide you the textbook, it looks like. And then they have actual like assignments that you can work through too. Oh, this one might not be the best one to do because I think they're talking about vectors. They might be doing multivariable calculus. Yeah, this website in general has actual like MIT courses that you can like follow through with. So I've done their linear algebra one, and I learned a lot from that. So here's a single variable. There's a few. Yeah. So this is a single variable calculus that actually has things posted here. Assignments with solutions, exams. So yeah, there's resources here. OpenStax. Oh yeah. What do they teach in high school? Oh, the normal high school progression here, Ayush, is not nearly that. It doesn't go nearly that far. Also, hi PhD. Funny enough, you feel like I'm slowly learning the real analysis theorems by hand. You know, if you could solve half these calculus examples. That's the weird thing. Like, being able to prove something that is not related to being able to apply it, I feel like. Yeah, so when I was in high school, like the minimum you had to do was Algebra 1, which I think is just like linear equations and maybe parabolas. Geometry, which is like not particularly advanced geometry, just like the angles on a triangle add to 180, alternating interior angles and stuff like that. Algebra 2, which I think goes deeper into parabolas and other types of polynomials, probably exponents and stuff. And that's as far as you have to go, at least when I was in high school. You can go farther and go into pre-calculus or statistics, or even as high as calculus, differential and integral. Oh yeah, I don't think Roxor is in America. Oh, you are? Never mind. I thought you were Canadian for some reason. I must be thinking of someone else. High school's 14 to 18 years old. Okay, so you want second derivatives for implicit equations. So first off, do you know how to do first derivatives with implicit equations? I assume you do if you're asking me this. So if I had something like y squared minus y is equal to maybe sine of x, could you find dy by dx here? The same in India? Okay. Right? good first step. And so the right side is just a standard derivative, so we get cosine of x. The left side is a little bit trickier. Y is a function of x. We don't know what it is, but we can kind of think of y as being like something involving x's. We don't know exactly what, but we know that y involves x's somewhere inside of it. And so, yeah, you're cutting straight to the chase. And so, whenever we take the derivative of y, we can pretend like it's an x. So this y squared becomes 2y. But because of the chain rule, this y has some x's hidden inside of it. We don't know what they look like, but we know the chain rule tells us we need to account for the derivative of whatever is there. So we multiply in a dy by dx. Yeah, exactly. It took me a really long time to understand that. I just, yeah. So I was exactly like you. Like, I just remembered to do it and I never questioned it, but eventually I realized why. And so, yeah, same thing here. The y becomes 1, but multiplied by dy by dx. And so, yeah, now we just want to isolate dy by dx so we can factor it out. Oops. And then we can divide the 2y minus 1 over. There we go. And so that's about the best that you can do. Like, we can't really get rid of that y there, so we just kind of leave it. If we wanted to find the second derivative now, we would take d by dx of each side again. And so we would get a quotient rule here, and that will become d squared y by dx squared. And then the quotient rule there, and remember we take the derivative of y to put a dy by dx there. I bet there could also be a situation... Well, could there be? No, there couldn't. I don't think so. I was wondering, if there's ever a situation where you can't isolate the dy by dx. I think you always can, though. Why is it d by dx instead of dy dx? It's because the notation for dy over dx is kind of confusing. It's technically better to write it as d over dx, like, of y. Almost. It's not... Actually, of y isn't quite right either, but this is another common way of writing it, and this is a little more clear. Like, they mean the same thing, but I think this one is a little bit more clear. I tend to write this just out of habit, but this is a bit more accurate as to what's actually happening. It's the derivative of y. They both mean derivative of y, but this one makes it seem like y is included in here, and it shouldn't be. Not getting rid of y rages me. Yeah, same. In Math Pond, thank you so much for the raid. How was your stream? I hope it was good. For people here on my end, check out Math Pond, a fellow math streamer, cool dude. I appreciate it. We're just talking to Ruxer about implicit differentiation here. Brain is so fried, I bet. It's, yeah, so this is a little bit better way to write it because it makes the next thing more clear, where we're like, if you take d by dx of d by dx y, that's why you get d squared dx squared y. And so we often do put the y up there, but it's maybe for the reason that you're pointing out, it's not quite so clear. I hope you get some rest, Math Bond. Something like sine of y over x. Thank you, thank you. Oh, I just repeated you back. You just said thank you, thank you. Then I said thank you, thank you. Well, hey, thank you, thank you. Yeah, pre-college math stuff and it's required. Oh yeah, trig is good to know. Sine of... So what are you doing with sine of y over x, Roxra? Oh, okay, yeah, we can do that. So yeah, we take d by dx of each side. Get d squared y dx squared. This is a quotient rule. Low d high. Low d high minus high d low. Low d high, so cosine y dy dx minus high d low, but derivative of x is just 1. Wait, there's no way I said it backwards a second time. Get me Paul. I need Paul. Am I washed up with this mnemonic like I'm getting old? Wait. Low, D high. Okay, no, I think I said it right. Yeah. And G is low. I think we're good. Apparently this mnemonic is dangerous. I'd never had issues with it before, I don't think. Then it's over x squared. Intermediate algebra covers algebra 2, the last half of it, algebra 1, college algebra. Ooh, nice. Geometry 2, just those two, everything else will fall on my lap. Yeah, geometry isn't as important for a lot of things, but it's good to know. So it comes up sometimes. I did not like the geometry classes that I had to take in high school. It gets cooler, in my opinion, if you keep on going with it. But yeah, it's kind of annoying. Okay, so I guess I'm gonna split this fraction up into two, because like this is pretty much the answer here, but we can make this simpler. X cosine y over x squared. I put the dy by dx off to the side here. Minus sine of y over x squared. You can graph on Desmos. Yeah, that's fair. So the x's can cancel, but more importantly, I want to get rid of this dy by dx just so I have a more like a cleaner formula. It's not wrong to have it here technically, but this thing is just simpler if we remember that dy by dx is equal to this. So I'm going to substitute that. Yeah, so that's like the one trick that you might want to know with second derivatives here. You might end up with a dy by dx, and it's a good practice to try and get rid of it. So these are actually going to have x squared as a denominator, so I can put them back into a fraction again. It's not really all that necessary, but... It's kind of a matter of opinion how you want to write this final form of the answer, but that's what I would say is the answer. Oh, that's a nice way of remembering it, Ayush. I've never seen it said that way. Yeah, that makes perfect sense. Been enjoying the textbooks they have me read, especially the artist. The artist. And so yeah, what Ayush is saying, or I'm sure you're saying wait about. Yeah. This dy over dx is the same as this dy over dx. So I subbed it. Calculus and linear algebra on my own. Oh, the writer. Okay. Fair enough. And it's not like it's wrong to have it there, but it's just like unsimplified, I would say. Right, so implicit because they're awkward with the dy by dx. Yeah, this notation for a derivative is always awkward. A lot of math notation just kind of gets more and more awkward. You have a product rule written in reverse order, but I mentioned, ooh, that is weird. A disguised derivative? I haven't heard that before. Let me Google it. Oh, yeah, send your problem. I don't like this type of problem. That's fair, Peach Tea. It doesn't actually matter which order. But like the alphabetic order just feels so much better. Yeah, it is. So these problems are kind of like trick questions. You don't have to do this limit in this way. But what they're talking about is the limit definition of a derivative, as you say. So limit of h goes to 0, f of x plus h minus f of x over h. Adjoint operators. Oh gosh. I bet if you ask that question at the right time, there'd be someone in chat who would know that. I the best I can do for you is a Stack Exchange thread, though, I think. No, yeah. I think if someone like Color Cone might know offhand. Because like I don't know about kind of operators generally, which I think is what you're asking about. So like this might be a good resource, but even then, like I don't know enough about this stuff to understand the explanation here. Yeah, sorry, you're just asking about a part of math that I'm not that familiar with. I've like I'm sure that I've like I guess to extend conjugate transpose. I mean, okay, this one makes more sense to me than the previous explanation. Yeah, because that's a Hermitian, and I've seen those before. And so like the Hermitian, what does that accomplish again? If you have a symmetric matrix of complex numbers, the Hermitian is the inverse. Or the same as the inverse, I think. So yeah, thank you for the question, but I think the stack change start is the best I can do for you probably. Read Axler? Yeah, Cook, let me get right on that. I'll have it done in 5 minutes. In Earendel SC, I'll talk about that in a second. I'm thinking of a unitary operator? Oh, okay, well. Never mind then. Okay, so Rookster, I think this is more of a trick question that isn't all that important. I can explain to you what the trick is though, because they do like to play similar tricks with other things like this, so it's good to know what the idea is at least. I feel like okay, but let me just quickly address Erendel's question. Infinity divided by 0 is infinity. I mean it's technically like technically that expression makes no sense, but in the limit sense, yes. If you have something that limit as x goes to 0 of e to the, well, of like 1 over x squared divided by x would be an example where you could think of this part as being infinity and this part as 0. This is going to equal infinity. It's like these two things are agreeing with each other. Like they're both blowing up to infinity, so they both agree that they want to be a really big positive number. Sorry, I should make this an x squared also, or any even power, just to make it cleaner. The equal sign hurts. Yeah, yeah, it's good enough for me, but yeah. Okay, so I don't think this guy's derivative stuff is all that helpful, but the point of this of what they're saying is that forget about this prompt for now. Just start with this, and I'm gonna conveniently randomly say f of x is equal to 5 over x squared. And I'm gonna randomly decide to calculate f prime of 2. And I'm gonna use the limit definition to do that because maybe now you can see where this is going. So f of x plus h, well, x is 2, so it's 2 plus h squared, minus f of x, 5 over 2 squared over h. And oh, look, magically, these two things match exactly. So now that we've shown this, we could just back up and take the derivative of this function and evaluate it at 2. That's the point of this problem. So minus 10 over x cubed. And then f prime of 2 is minus 10 over 8. It's minus 5 over 4. Oh yeah, so that definition with f of x and f of a is completely equivalent to this definition here. But for the purposes of this question, it's better to use this definition because they match more closely. And yeah, and PhD gives the it's just a change of variables that separates them. But just with the format that they've asked the question, this definition is more natural to use. Either is acceptable though. So yeah, sorry, I kind of zoomed ahead, but and so yeah, as a use shed, you could just treat this as a normal limit problem and just calculate it too. Like that's absolutely possible here, and you would get the same result. So you, like, yeah, that. Oh yeah, sure. I don't think this type of question is really all that helpful to know. It's not bad to know this trick. The really evil version of this question is when they give you a random sum of something that looks super crazy, but it turns out to be a Riemann sum, and you can say it's equal to the integral of something. That's my least favorite type of problem. But yeah, it's possible to do a disguised integral too. Okay. So if we so if we were doing this problem blind and we weren't told it's a disguised derivative, the thing you'd have to hope that you notice is we have the same function here, 6 arctan. They both have the same, besides ignoring the h, they both have a 1 plugged into them. So we just have to notice, and we may not, but f of x plus h here is 6 arctan, I guess x plus h. And this is our f of x. So you just have to like notice this, and it's not easy to notice if you haven't seen this trick before. It's asked frequently in JE exam here. That's terrible. So what we can say is if f of x is equal to 6 arctan x, then f prime evaluated at 1 is the limit, oops, as h goes to 0, 6 arctan 1 plus h minus 6 arctan 1 over h. So these two things are completely the same. And the left side is easier to work with. So we can choose to work with the left side instead. Can we do this arctan of 1? Is that pi over 4? It must be, right? No, arctan of... What's up, Tizzer? Wait, does this limit even converge? It is pi over 4. Oh, yes. Okay, yeah. No, it'll converge. I was getting weirded out. But yeah, so I guess I can actually find this too. F prime, the derivative of arctan is 1 over 1 plus x squared. So f prime of 1 is 6 times 1 over 1 plus 1 squared. So it's 6 times a half, which is 3. The formatting of this question looks really weird, Tizzer. Can you maybe clean this up a little bit? Because I think there's something got duplicated. Or there's maybe some fractions involved here. Limit with h to 0 is 3. Yeah, if we were to compute this limit, we should get 3 at the other end of it. I think we need to use L'Hopital's rule here. Or power series, I guess, but... yeah, this limit is a little bit more difficult to compute. So this one is a better limit to use for this type of question, because I think it is a lot easier to just do this derivative thing. Yeah, if you were to compute the limit, you get 3 also. I'm starting to get a little bit tired. I don't want to stream for a lot longer, but I want to see if Tizzer can repost their question with better formatting. True, yeah. Floppy. And also true to Ayush. I didn't know that formula. And so a really nice application of implicit differentiation is, as Floppy is saying, if you want to find out, if you have y equals to inverse sine, I'll write it like this. I prefer saying arc sine, but I feel like that kind of weirds a lot of people out, so I'll write inverse sine like that. If you want to know what y prime is, and you want to find the derivative basically of inverse sine, you can use implicit differentiation there. So what you would do is say that sine of y equals x, and then take d by dx of each side. And you have a little bit of tricky algebra, but you'll eventually be able to find that y prime is 1 over root 1 minus x squared, I think, if I have that right. Why about this notation? I don't like the little -1, because it makes people think of 1 over sine, and it's not that. It's a different thing. Oh, why use implicit? Because... and Tizzer, I see your question. Thank you for cleaning it up. I'll get to it in a second. Because I don't know the derivative of... or this is, like, you know, if we don't know what the derivative of inverse sine is directly, this is a way that you can show it without having to use... it's like the alternative for finding the the derivative of that would be using limits. And if you want to evaluate this limit, be my guest. I would rather not, though. Okay, so fan of arc sign is that the inverse sign implicit. Yeah. Let's take a look at Tizzer's question. Yeah, Taylor series will work too. No worries, Roxer. If you have some more like small ones, I can keep on answering some questions, but I think Tizzer will be the last big question of the day here. Okay. Well, the first part I definitely know how to do. The second part, I'm not so sure. The integral, that's an interesting one. The derivative, I can definitely tell you that. The integral is probably going to need some trick that I don't know. So, way to figure out the compositional inverse of a Taylor series. Oh, interesting. So it's actually a great place to use implicit differentiation. I guess technically like logarithmic differentiation is also called. I'm going to take the natural log of each side. BC not AB. Yeah, I mean, you seem to be picking up calculus really quick, and if you already know calculus before you even take it, you should just go for BC. So yeah, the reason that I want to take ln here is that it's going to make this so much easier. And so yeah, works even for you. This is like an interesting technique to see here. So using log identities, I can split this thing up. So I'll write out the steps a little bit individually. We'll get ln x to the x minus ln 1 plus x to the 1 plus x. And then we can use the power rule for logs. X ln x. So, Roxer, I personally skipped calculus AB and went straight to BC. And I didn't even know anything that you know right now before even taking calculus class. I think you can definitely do it. Oh, that's true, Ayush, yeah. That's a fair enough point. Okay, and so now that we have it in this form, I'm going to take the derivative of each side. So 1 over f of x, f prime x, product rule here, ln x plus x times 1 over x is 1, minus product rule here, uh, 1 over x times 1 over x is 1. Nice having plus in math here. Wow. That's a high standard. Holy crap. I'm going to multiply this f of x to the other side. This one cancels with this one because of this minus sign. So we get ln x minus ln 1 plus x with an f of x outside. We can use log rules on that. Ln x over 1 plus x. And then f of x we can remember is equal to this. Hey, Doomwood. The AP test was reasonable for me. It's not like easy, but like I did well on it. I think you'll do well on it. The difference between A, B, and B, C. Yeah, the polar coordinates are tricky. Series, logistic, exponential growth and decay. Yeah. So yes, also we're talking about AP classes, which is an American thing. When you're in high school, AP classes are college or university level classes that you can take in high school still. 360 no scope the BC exam. And I'll get to the max value in a second. And so in America, there's two calculus classes. AB is just differential calculus and the beginning part of integral calculus. B in an entire high school year. BC is an entire high school year where you go over differential and integral calculus, polar coordinates, power series, and maybe something else that I'm forgetting. Yeah, it's for Calc 1 and Calc 2, basically. Oh, nice. And so I can pass that link along to the YouTube chat, too. And so if you take an AP class in high school, you can often, depending on the university, not have to take your calculus class at university and just go straight to harder math classes. Oh, nice, Peachy. That's a good one, too. I did both. Okay, so to find the maximum, we want to find where the derivative equals 0. Kind of like A-level further math? Yeah, I think so. Okay, so the denominator can never give us 0. We don't have to worry about that. So we can kind of split up into cases. Either the ln is equal to 0, or x to the x is equal to 0. I'm just going to give you a spoiler alert. This never happens, though. If you try to plug in 0, you get 0 to the 0, and that's basically going to be equal to 1. I don't think there's any value of x that makes this equation true. So let's just focus on the ln piece. So I'm going to do e to the power of each side. X over 1 plus x is equal to e to the 0, which is 1. And now just solve this for x. So x is equal to 1 plus x. Oh, well, that's not good. Really? That's never equal to 0 either? Oh, you're never 0. Look at you. Huh. Yeah, a Taylor series is something that you'll learn about if you keep going in calculus. That's like after you go through all of integrals, though. Well, crap. It does have a maximum. Yeah, Tizzer, this is not an easy problem. So what you'd have to do is... Okay, so what we can show... For positive x, this piece is always positive. For positive x, however, this piece is always negative because it's ln of something less than 1. So the derivative is always negative when x is greater than 0. And so that means it's always, the function is always decreasing. Its maximum has to be at x equals 0, basically. And so we saw from Desmos that's going to be 1 when x equals 0. Actually showing that, though, is a little bit tough. You have to take the limit of this thing as x approaches 0, and that's not easy. I think you have to use L'Hopital's. So yeah, I might need to call it here on your problem, because the integral piece, I still have no idea. Like, how would you possibly integrate this? No, it's something that you'll probably learn about soon. Roxer, it's called L'Hopital. It's a helpful trick for evaluating limits. Yeah. And so I guess we should get like 1/1, basically. Oh, Zach, that's true. Maybe there's an integration by parts or something. But yeah, that is true. So maybe the integral is possible. Yeah, yeah. Well, we already know what f of x is. That's given to us in the problem, right? So one guy is onto something. Oh wait, Tizar, are you asking what L'Hopital's is also? Actually, could you do the limit? Can I take the limit of this as x goes to 0? I think that's valid. I know that's easier. You are asking what L'Hopital's is? Okay, if you don't know L'Hopital's, that's... A little bit tough to do this limit. E2 to pi is 1. It's equal to 1. Okay, so the thing that I was hoping to avoid explaining is how you would evaluate this limit here. Oh wait, actually it's not even L'Hopital's. You know what we're trying to do? You just say things. I think you're onto something though. I think you are. Actually, I don't think this limit is as bad as I'm making it. I would start by evaluating just the limit as x goes to 0 from the right of x to the x. It's a dirty trick, but you can assume it's equal to L, some number L, and take the log of both sides. It's actually, yeah, you don't need L'Hopital's for this. Or, well, maybe we will in a second. Um, using limit properties, the ln can come inside of the limit. And then that gives us a nice property here. X ln x. ln of 0 is negative infinity. Yeah. We should get 1. And your Marth tests? Is that like a Super Smash Bros. Test? I know what you mean, though. Your teacher will probably be annoyed or amused. I don't know, depending on the teacher. Does it have to be defined? Yeah, but they're asking for the maximum value, though. YouTube isn't showing your chats? Oh, I'm sorry. Sometimes YouTube like randomly censors things. Oh, yeah, we do need L'Hopitals for this, I guess. So the point is I've written this function in a way where like the top is negative infinity and the bottom is infinity, and infinity divided by infinity is considered an indeterminate form. I think I'm not going to get 1 out of this is a problem. Oh wait, well, we want 0 actually. That makes sense. Okay. And so when you have an indeterminate form, you can apply L'Hopital's rule, and all that says is I like to put an LH above the equal sign to say that I've used it here. You can take the derivative of the top and take the derivative of the bottom, and you'll get the same result for the limit. It's like this. And now we can simplify it. Hey, color cone. So we're going to end up with minus x, so we just get 0. But remember, this is equal to ln of L. So the limit of x to the x is e to the 0, which is 1. So that's why, so the limit of x to the x as x goes 0 from the right is 1, from the work that I did down here. The limit as x goes to 0 from the right of 1 plus x to the 1 plus x is also 1. It is a really confusing thing. This is not an easy limit to compute. And if you haven't seen L'Hopitals before, that makes it even weirder. So I'm sorry about that. This is just a change of variables from this. There's nothing substantively different. Like, you could go through the same process, or you could just, like, take u equal to x plus 1. Or, I guess, x equals u plus 1 or something. But, yeah. And so, since the top and the bottom are both 1, this overall limit is just 1 divided by 1, which is just 1. And so the point of doing that is that's our maximum value, because... Oh, actually, no, we need to... I never heard of a motion graph, I'm not sure. We also need to... Okay, I'm sorry, Tizzer, I'm just getting too tired to actually follow through with this question. They're asking for the maximum. We've shown the derivative is always negative, which means the maximum must occur at one of the endpoints. Well, actually, no, I think we are done. Because they said maximum. And I think we've just shown that the maximum is 1. Yeah, okay. If they said, like, the maximum of the absolute value or something, or... I was concerned that... Yeah, it's 1. I was concerned that the function could, like, go off to negative infinity, but we don't have to worry about that. Like, that would be a minimum. So for the maximum piece, we're done. The two steps are showing the derivative is negative and then checking the left endpoint, which is 0. My two favorite genres are metal and rap. Famish. Yeah, okay, and so let's... Zach did point something out interesting with the integral. My approach after the log step? Like here? Or earlier when doing the derivative? I don't feel like I'm winning. I don't know. Okay, yes. Oh, up here, yes. So the reason I took the log is I want to take the derivative of f of x. This is a terrible thing to try to take the derivative of directly. It just doesn't really work. So how you deal with this is take the natural log of each side. Because natural logs have properties that are really useful here. First, we can split up this division into a subtraction. And then we can take the exponents and put them out front. So that's the point of taking logs. I don't know what that means, Dr. Cook, but I saw you took it back anyway. Now you get, okay, good. And then from there, it's just implicit differentiation. Okay. Anything from the 40s to the 2010s. Nice. I mean, I guess that's... One was Frank Sinatra active. Like, I like Frank Sinatra. 50s, I think. So yeah, for the integral piece, I think Zach is on to something. Because this is f of x. And Zach did point out that f prime of x is equal to ln x over 1 plus x times f of x. And it feels like something about this could be helpful for this integral. I'm not quite sure what yet, though. Basically Zone Ranger, yeah. Or at least x to the x. As x goes to 0 from the right. Why are you confused, Roxra? Been banging at the integral since you guys have been doing limit. I don't think you reach anything nice and integrable. Oh. Nina Simone, Frank Sinatra, Hank Williams. Oh, nice. Oh, the motion graphs. Yeah, I mean, maybe I've seen them before, but I'm not familiar with that term. I think the question was to actually integrate it. Yeah. Oh, I see what this is, Roxra. Ah. Oh shoot. Okay. I don't have much. I want to turn the stream off soon because I got some fried chicken to go get. So yeah, if someone has an idea for the integral, let me know, but I would need to play around with it a lot. Chicken lava? I don't know what chicken lava is. Just just regular fried chicken. Is the object moving forward, backward, or neither? Yeah, I'm sorry. I don't have a good idea for this. If you're in the Discord, someone might post an idea in there, but I'm not sure. But at least I could answer part of the question at least. Oh, from the Minecraft movie. For each one of the graphs, object moving forward, backward, or neither. These questions can be really tricky. So they're giving us velocity and they're giving us time. I think this one is... This one we don't need to overthink. I'm worried that I'm underthinking it, but I think it's just... If you're moving forward, that means your velocity is positive. Surely, right? So I would think these first two should be forward, and if your velocity is negative, you're moving backwards, so the last two should be backwards. And if you were right at 0, that would be neither. Oh god, Zach. Chicken jockey. I know that one. It was right? Okay. Pretty bold, you assume positive 4. That's true. Doomwood. Okay. I think it's gonna have to be it for me, Tizzer. I'm sorry we could only do half your question, but yeah, it's gonna take it would take me a long time to figure out the other part if I even could. Is this the song? Oh yeah. This will be a good thing to go out on. I never have seen the Minecraft movie. This looks so goofy. Oh, I've heard people singing this. This sounds familiar. Okay. Lava chicken. Oh, hey, in the background of that scene, I had a lava snake, which is kind of close. Okay. Anyway, I'm cutting the YouTube stream off here. Doomwood, Ayush, Tizzer, anyone else who's here on YouTube, thanks for being here. On Twitch, we'll look for a raid. See ya, YouTube.